Okay, so in the last video we used an environment light to set up our diffuse component, but we've seen there are some limitations in doing this, and I think the largest issue right now is really with the lack of control we get over this image. This image is our diffuse pass, and it's a single image, and that means that all of the light information, all of the shadows, and all of the surface color are combined, and that makes it really difficult to manipulate each of these individually when compositing. And it also means if I want to change any one of these three properties, I'm going to have to re-render all of them. For example, let's say that I don't like our checkerboard as our diffuse surface color. I'd rather apply maybe a wooden floor texture for our floor and something that's more representative of a teapot to our teapot. If I change just that diffuse surface color, I now have to recalculate all of the lighting and all of the shadow information, even though neither of those pieces of information have changed. The only thing that's changed is the diffuse surface color. And that's really, really inefficient. So we could work with our environment light and we could turn off shadows to get just the light on its own, and then we could apply a shadow map shader to our objects to get just the shadows in their own pass, etc. But I mean, this requires a lot of us in terms of setup, and we'd actually have to do this setup for every scene that we wanted to utilize our shader in, which means that we'd be making changes in different parts of the network. We'd be creating a light, dropping in an instance of a shader, we'd be setting properties on the light, we'd be creating multiple shaders and assigning those to objects for every scene, and more importantly for every object that wanted to make use of our HDRI for the lighting. So I sort of came to the conclusion that it would surely be better if we could encapsulate all of the functionality of our diffuse passes into a single shader, so that by simply using our shader, by creating an instance of our shader and applying it to an object, we are going to get all of the passes that we need. We don't have to worry about creating other shaders. We don't have to worry about creating an environment light. We're just going to have everything encapsulated in a single shader, which means that we only need to create one instance of that shader for one particular use, if you will. Obviously, if we want to have multiple objects with different properties, then we'd need multiple instances, but for argument's sake, one instance of that shader, and we'd simply use that shader and render the different passes that shader provides, and we wouldn't have to worry about jumping about in different places in our scene file to set up those various passes. Now, another advantage of working directly in the shader actually relates to how the environment light calculates illumination. If we take a look back at this image where we're dealing without shadows, and again I did mention this in the previous video, we can see that there is still some noise here. I think this would be great or more greatly accented if I was to set the area samples back down to 16 on our environment light and re-render. So if we take a look at re-rendering with just 16 samples, look at all of the noise that we're dealing with. I didn't turn off shadows, so obviously we're going to have noise in our shadows as well, and I wanted to demonstrate that noise was not just in our shadows but actually in our illumination. Just give this a second to render. There we go. Look at all of the noise in our illumination. This is really quite inefficient because it means that the earlier processing we did of our HDRI to use as a diffuse environment, where we simply needed to use a normal base lookup, just simply isn't really being taken advantage of, because we're still using a sample-based method to calculate the diffuse lighting here, and we really don't need to use a sample-based method. All we need to use is a normal base lookup, which would be much more efficient, and that means our render for a pass like this, which just has diffuse lighting in, would be a lot quicker than the current render times we're experiencing. Now we can also notice, let me remove this image. There we go. In this frame here, there are sort of some inaccuracies, if you will, with the shadowing, especially around the bottom of our teapot. I mean, it doesn't really look like the teapot sat properly on the plane, and these inaccuracies are just the nature of the way the environment light is working. But the method that we use we'll implement over the next few videos for generating our shadows actually generates them in a slightly different way. And I personally prefer the shadows using the method we're about to approach over the shadows that get generated from the environment light. So that's just sort of another note of one of the advantages we're going to get from taking this alternative approach to using an environment light to set up our diffuse component. So over the series of videos that are going to be coming up, we're actually going to break our diffuse pass down into 3 different passes. Let's jump over to the whiteboard. And we're going to break it down into 3 passes. Those passes are going to be, as I've managed to drop my opacity way down. Let's boost that back up. There we go. So this is going to be our diffuse light, or diffuse lighting. So that is just the lighting information, no shadowing information, no surface color information, just the lighting information. We're also going to have our diffuse shadows. So that's any shadows that are caused because of our diffuse lighting. And finally, we're going to have our diffuse surface color. And this is going to be just the color of our surface. In a way, you could think of this as what color of light does our surface, in terms of diffuse light, does our surface reflect? And we can then recombine each of these 3 passes very easily by multiplying them together. We simply need to multiply these all together, and that will give us our final diffuse component. And this makes sense if we think about it, because we can start out with just our lighting information, and then if we take our shadows and if we generate an image for our shadows that has black in the image, in the color of the image where we have shadows, and white where we don't, and we multiply that in with our lighting, well, anywhere that we have shadows is going to have a value that's darker than white, which means that we're going to be multiplying whatever our lighting information is by a number smaller than 1, which means that our lighting is going to become darker as a result of our shadows, which is exactly what shadows are. They are a lack of lighting. So if we had pure shadow, complete black in our shadow pass, and we multiply that in with our lighting, it doesn't matter what lighting information is there, we're going to get pure black in the result for our diffuse. So the multiply of those 2 works fantastically. We can also think of then multiplying in our diffuse surface color. Whatever our diffuse lighting is doing, we know that we could have any color of light, but whatever light hits our surface, only the colors of light that our surface will reflect are going to actually be seen, or actually going to be reflected into our camera. So we can take the diffuse surface color, and if we multiply it with whatever lighting is available, whatever lighting's hitting that surface, that's going to tell us the true color of light that gets reflected off that surface. For example, let's say that my diffuse lighting had just a red value, so it had 1 in, let's say a full value of 1 in red, 0 in blue, and 0 in green. And then our diffuse surface color was pure blue. Well, our blue surface is not going to reflect any red, so 1 times 0 for the red components gives us 0, and 0 times 1 for the blue components gives us 0. On the other hand, if I then change my surface to, instead of being a blue surface to being a red surface, it would reflect all of the light, because 1 times 1 gives us 1. So by multiplying in the diffuse surface color with the resultant lighting, that's going to give us only the light that gets reflected based off of our surface color. And this comes from basic light models. If you were to look into the equations that are under the hood of very basic light models like the Lambert lighting model, you'll see that the color that we can set for a surface is multiplied in by the lighting information, and that gives us the final result. Now obviously in compositing we don't have the ability to multiply together 3 passes, we can only multiply 2 at a time, so in actuality it's going to look something more like this. So we've got our 3 passes, we multiply 2 together, and then we multiply in the third. But the nice thing here is that actually these 3 passes, the way they multiply together is associative, so that means the order of operations doesn't matter. We could multiply the shadows and surface color together first, and then the result of that with that diffuse lighting, or we could multiply the diffuse lighting and the surface color first, and result of that with shadows. It really doesn't matter the order because it's associative. The order of the 2 multiplications just doesn't matter. Now, all 3 of these passes are going to be output from our shader, directly from our shader. That means that any scene that is making use of our shader instantly gets access to those 3 passes. Now, the initial approach that we take for our shadows is actually not going to give us quite the results we're after, and we will discuss that when we get to it. But it's just worth noting that our final set of diffuse passes is going to vary very slightly from this, but in principle, this is exactly what we're going for. So over the next series of videos, we're going to discuss and implement each of these various passes in turn. And we'll also look, as we're doing that, at comparing it back to the results we were getting with the environment light, and also looking at how we're combining them through compositing to get our final diffuse component. So with that, that does conclude this overview, if you will, of the approach we're going to be taking, and in the next video we'll begin looking at diffuse lighting in detail. Thanks a lot, everyone.